So let us continue. Maybe you have the music from the OBS. Someone like try to serve as a ringing bell, right? All right, so the previous class we already have the generalized forwarding, but not finished because we should have the example. And right now we have the continuous discussion for the example. And also later we will have the finished discussion by checking the middle boxes and the fragmentation and reassembly. Well, so let us continue. Here we have the example. We have the goal H5 and 6 to H3 and 4 via S1 and finally to S2. So the action force we want to have the flow table. And right now, H5 and 3 we have addresses and within the domain 10.3. So we have these 10.3. So this is addresses. It's true. For 5 and 6, it's okay. And we want to have the destination. Destination actually it's a subnet here. So it's okay as well. All right. And furthermore, we want to from the current switch S3 to S1. So S1 here. So forwarding, the pole number should be 3. For the current setting of the flow table, it's okay, right? Of course, it's a destination-based example, so it's easy. But the current one, we want to make sure from this switch. All right, so ingress port, it should be 1 because we know from S3. And yes, destination same, IP and destination same. So the current one, actually, this is the difference compared with the previous flow table. And likewise, we have this direction. So pole number 4. And finally, this one, yes, we can have the ingress pole from current is 2. So 2 and 2, but right now we have 2 destinations, so we need to have destination 1. All right, destination 1 is H3. So H3 should go to port 3, and H4 should go to port 4. Well, the current one actually we can pass on the forwarding table, but it's the flow table. All right, because of a flow table, so we want to make it different. At least we have the ingress pole. All right, ingress pole. And so that at least this one, it won't be identical to the forwarding table simply. Well, so this is an example. The example, of course, is the simple example. And at least we just let you know, yes, based on the concept of generalized forwarding. Of course, we can reach the destination-based forwarding. And of course, we can have the implementation for the other functions. All right, so this is the example based on destination-based forwarding. So this is a summarize. Yes, generalized forwarding, mainly based on the match plus action, then we can achieve the forwarding and the other services. So we should have the pattern matching. All right. And we can have the actions. And actually, we can have the network-wide behaviors, but we skip it. So we allow to have the programmable processing and service. And then, yes, it's true. We can achieve it. And so that based on that one, it's SDN. So today, we can have the generalized programming. All right. And actually, you can check specific one, P4. And P4, what it means, you can use a key term P4 and the SDN, then you can have the results. And that's all. So this is a discussion for generalized forwarding. Well, up to now is okay. We just have the key term. Sorry, the key concept, the pattern, and the action. And next one, let us go to the further discussion about middle boxes. And why we have middle boxes and the evolution of middle boxes on the internet. Well, maybe up to now you may have a question. What it means, middle boxes. This one, this is a definition of middle box using one RFC. So you can check it for 1 minute. All right, so I push you to think about these middle boxes. So, which one belong to the so-called middle boxes? Now, let us check it. Of course, NAT, firewalls, IDS, and load balancers, and some application-specific one, then all contained within the middle boxes. So initially we have some framework or at least the architecture net. Something like it's the fundamental one. So middle boxes everywhere. All right, we already have other examples. And in fact, for middle boxes, they start initially from the proprietary solution and actually the hardware solution. Why? Because you don't have the function, so I provide you the function. And also, the company can make money. Of course, they want to do that one. And later, of course, we'll try to have, of course, even we have that one. But we want to move towards, here we go, white box hardware using open API. That says, oh, not only for the proprietary solution, we want to have the public solution. And finally, to the destination in software. So middle boxes starting from the hardware, from proprietary, and even go to the intermediate one. Yes, still the white box hardware. But finally, we want to move towards to the innovation and differentiation in software. Then we can achieve programmable, the concept of programmable. Well, so because of those concepts, then we can use the concept of middle boxes and work with SDN. All right. If we have SDN, and why SDN? provide us the middle boxes here, this one. Network Function Virtualization, NFV. NFV allows us to have the programmable service. All right, and this one actually serving as the third stage. And the third stage, then we can have the service over the second stage, white box networking. And actually, if still we want to do something else, then do you think we can have the service over the proprietary one? Because of a proprietary one, so we cannot guarantee that one. So we don't mention that one. At least we have the third stage programmable service over the second stage white box networking. So it's okay. So this is the original concept of the TCP/IP. Specifically, we focus on IP layer. And we have a TCP UDP. Okay, we have app layer up now. Everything's okay. And for IP, it says the IP support the other apps, right? And TCP UDP, that's okay. And it's thin. It's thin, so we have a thin west. Somewhat we have the close and our body to check this, but currently it's not our body, it's the internet. So initially for the internet, we expect to have the thin west. Why we want to do this? Because we have the actual one. The actual one serving as the middle one, so because of middle one, so we have the middle boxes. So we can use the concept of hourglass silo. So hourglass, then we can have the concept like the current one. Well, why we think IP is really important and IP is a necessary one because of this. IP implemented by every internet connected devices. So it's really important. Importance, of course, is a common one. So up to now, the concept we just want to have the public one, the common one, commonly used service or protocols. Of course, IP support many other layer protocols. Because of this many, so this many goes to the concept of hourglass for IP. Here, we already have the key term in Chinese already, but this is the keywords from Cambridge Dictionary. And west here. And for the current discussion, we have middle boxes. Middle, here, middle. Because of more functions, so sometimes we have the extension. So it's not normal thing. And so that it's a box. Many boxes here. And sometimes many boxes here. We can have the concept middle age. Middle age of human beings. And middle age, so we have the term love handles. Well, maybe you have a question what it means, love handles. This one. Middle age and love handles. Right? Yeah, true. So that's why we want to use a current example, hourglass, and also the west of human beings. And because of the extension, so we have the love handles of the internet. And we already have NAT, we have the web caching, we have NFV, we have a firewall. So we want to have more. Therefore, it's not normal IP simply. Therefore, we have more middle buses. For the middle buses, because we want to use them, so they exist with IP layer. And yes, why we want to have the functions more than IP? Because we think it's necessary, or they are necessary. And right now, we already have something like here. If you try to figure out the principle for internet, architectural principle of internet, what's that? Same, allow you to have 1 minute to check this one, and later we can continue. So this one asks you to think about if we want to have architectural principle. And in fact, we have this. Should we have it? Of course, finally, should be yes. But yes, and then should we have the new elements? For different age, we have the different elements. And of course, currently, we emphasize the specific one, intelligence. So actually, in the past, maybe we have the concept, oh, it's useful, so we want to provide. From the proprietary concept, we want to implement using the hardware. And right now, we want to open to everyone. So we have SDN, and beyond SDN, should we have the others? And so that we have the clear architecture for the internet. It's yes, for the current age. We still think, yes, we want to have the simple connectivity for the internet. We want to have the basic one, IP, but beyond this, and then can we have intelligence as well? Because we want to combine AI into the internet. In fact, we do that one as well. But we have the possible way to have it. So this is a functionality. And originally, we have the N to N, and so that we have the router. So routers. So up to now, we have the concept from the house to house. And actually, no, not house to house. We have house to router, 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 router. Actually, we can do the switch. But we think we have the element of a network layer. So yes, even you think the concept should from the house to the house, but we have the many one, and many ones so that we have one. It's edge. Router, someone like serving as the edge. So we have the new concept edge. Network edge. And in fact, we just want to let you know, don't ignore the existence of a network edge. And because of a network edge, initially we want to have the light loaded. Why? Because of originally it's the cold. core of the internet. We have the main brain of the internet. And because of the concept of network edge, so we want to move the functionality of a brain to the edge. All right, so yeah, we have the networking, but still we want to have the intelligence. But intelligence we have heavy loaded. Heavy loaded, so how to shift the loaded to the edge? We can use the edge computing. And this is the middle edge. Move it to the edge. But finally, yes, we have the intelligence at edge. However, we still want to have the control for the core network. But this time, at least the brain becomes a bit smaller. That says the load becomes light, and so that it won't be necessary to always control by the network code. So network code and the network edge work together along with the AI, then we can achieve it. So this is the current concept for networking and the AI, or the intelligence. Initially, yeah, the server can control everything, but later within, we have the limitation. So we move the computing capability to the edge, network edge. Finally, network code and network edge working with the AI, and so that we can provide service to all the end users. All right, so up to now, we reach the current stage here. The final one. All right, so this is a discussion for the current chapter. We have the overview, and we check what's inside the router, IP protocol, and generalized forwarding. Of course, we based on the concept of open flow and SDN. And in chapter 5, we will continue that one. But we will have the traditional routing first. And of course, we already have the middle buses and Arduino. Yes, we still need to rely on some architecture. Even we have the new element, for example, AI intelligence or something else. So we already have the remaining discussion talking about fragmentation and reassembly. Actually, this one should be discussed a bit earlier, but the current version, the author think maybe we can skip if we don't have enough time. But yes, we have time, so we go through the slides for sure. And we have fragmentation, so we want to split the whole datagram into the smaller datagrams. Here, we can see we have the smaller datagrams. Perhaps we have one larger datagram to the 3 smaller datagrams. And to the smaller datagram, then we have overhead because we have the headers. So it doesn't mean we should have many smaller datagrams. We will have the proper design. And is it okay to have the new datagram again? Possibly. We may have the others. But currently, we just have larger one and smaller one. We have 2 sizes here. And once we reach the destination, of course, we need to reassemble. So we can reassemble the 3 datagrams to a single one. And the function we call reassembly. And so that we can get the original datagram sent from the source. So this is the idea we want to do, but we want to really have the details about the fragmentation. This one. And in fact, we have the TPS later. And for example, we already have 4,000 bytes for the datagram. And we define the MTU. The MTU actually we will have the selected value. And currently we select the MTU. MTU means, all right, the current size. 4 byte means the original one, but right now we have the smaller one. 4,000 actually is the original size, but currently we want to have the smaller size. The smaller size including, don't forget, including 20 bytes. Of IP header. All right, so initially we have 4,000 and then fragmentation, no, so flag 0, offset 0. And the ID here is common. Actually, we assume we have the current ID X. And we want to split the whole one into 3, like the previous example. And right now the length is 1,500, but the remaining one should be this. And maybe you have a question, how to have the calculation. It should be this. Originally we have all right, so this is the payload. Okay, this is a payload, so we can continue to have the first one. Yes, the first one, the size is this, but the size here. Likewise, we have 1,500 minus 20, so we have this one. And for the offset, initially same for the first one, starting from the starting point is 0. But how to have the offset for the next one? We pass on this one because we have these. The first one is 0, and next one here. So we pass on this one to have the calculation. But pass on this one to have the calculation. How to have the calculation? We should minus the overhead 20. So we have the current size 1,480. So based on this, how to have the offset calculation? The offset based on this one, the current value over 8. Why 8? I already have maybe the reminder when we have the IP datagram. Offset, before offset, we have 3 bits for the flag. Because of the 3 bits of a flag, we want to have a smaller number. A smaller number, so we divide 8. All right, so for that reason, we divide 8. It doesn't mean, okay, it's byte here. So over by what's the unit? No, we just want to have the smaller number, and so that the smaller number can fit the field without the size of flags. Flags occupy 3 bits. All right, so for that reason, over 8. Once over 8, then we have the number. And so that we put the number to the offset here. And likewise for the next one, offset should be this one plus this one. So we have 370. Well, up to now, I think offset, no problem for you. 0 and 85 and 370. And for flag, flag means, okay, we still have the next datagram. If one yes, say yes. So one yes, but the final one no. No further datagram, so 110. And for the size, 1,100, 1,500. Yes, we have it, but the remaining one, why? We have the value. I want to ask you to check these. Actually, we have, and if we have this one, and we have this, and this one equal to this exactly. Right? So the parallel, it should be 1020 plus the header. So we have the size 140. All right, so for the current calculation, feel free to have the discussion with your neighbor for you for 2 minutes. Okay, go and check it. I stop here and let it check for the details. All right, so maybe somewhat noisy, but I think maybe that it have the sound so they keep you focusing on something and you won't go to sleep. All right, so for the current operation, to have the fragmentation and so that, oh, I forgot to mention IDX, so we don't have the change for IDX. X here, X and X. So for all the fields here, we have length, ID, flag, and offset. About the calculation up to now, any questions? It should be easy, right? But I didn't have the reason why over 8. All right, even over 8, it doesn't mean we have a byte. Over 8, then what's the new unit? No, we don't have the new unit. We just want to make the current number smaller so that the small number can be fit within the fields without the 3 bits for the flag. All right, let me mention in Chinese quickly. 除以8其实想法或许这是我其实帮它赋予上去。我们有3个 bit flag 已经把数字变小了，所以我们不希望数字太大，摆不进少了3个 bit 的栏位。So for that reason, we have over 8. But maybe you have a question, why we want to define something like that one so that we have new story? Well, I think these one are specified in the spec, so I cannot let you know the other reason, only the current reason. Yeah, we have something like that, and so that we can allow all the possible value carried by the datagram, the smaller datagram. All right, so this is the IP fragmentation and reassembly, actually focusing on fragmentation details only. As for the reassembly, it's easy, put them together, then we have the original one. All right, so this is the actual exercise. And for the actual exercise later, we will already have 1 TPS. And finally, yes, we have many functions. Specifically, we have the function of network layer. And is it possible to have the observation? You can try to download the Wireshark. And you can use Wireshark to observe something. For example, oh, we want to have the observation for DHCP. And you can have the possible snapshot for the request and response part. And how to have the further discussion, you can try to check it by using Wireshark tool. All right, so we have the example DHCP to that use Wireshark. If you want to do that one, try to download Wireshark. So that one for your reference. And let us close the current section, current chapter. Oh, sorry, it should be, I forgot the change for the part here. It should be chapter 4. All right, I forgot to change this one. So reflection on chapter 4, not chapter 3. And it's true, yeah, this one. The similar action I ask you to do, because we reach the end of chapter 4, so we think about what kind of concepts or techniques or terms you have. And of course, if you think you learn well, that's fine. You can put them on Paul article later. Or maybe you think, okay, you still keep some of them, then you can mention those on the Paul article. So we have these. Ask you to have the reflection quickly. And this time, I go to the current questionnaire directly. So ask you to think about what kind of key terms you have, and you can put on these. Same 2 minutes for you to finish the questionnaire. Yeah, it's true. For some of you, move SDN, that's correct, because SDN in chapter 5. And it's really important. We talk about data plane, that's correct, for the current chapter. And yes, we have IPv4 and v6. But specifically, we devote our discussion to IPv6 because this is the actual one. And yes, we have forwarding, we have middle buses, and because of IPv6, we have tunneling. Okay, good. And OpenFlow, we mentioned that one, but OpenFlow will be covered in the next chapter. Of course, we mentioned OpenFlow. And we have the details for routers. That's correct. Because of IPv4 discussed today, so you have IPv6. That's okay, no problem. So I think, yes, I just push you to think about the key terms and concepts covered by the current chapter, chapter 4. Of course, some of you mentioned some of the points, lots of points. Maybe I will check them. I expect you to let me have the email again for the questionnaire for the EMI, from the EMI initiative. So it should be the OBEI, all right, Office of Bilingual Education Initiative. So from OBEI of our school. So if you have some question there, possibly also forward the email to me to check again. All right, so for the activity, I think that's okay. You still remember some of them and maybe most of them. So that's okay, good. Let me move on to the next one. Yes, right now, we still have the problem here. Similar to the previous one, but we already have the new description. The size, MTU size, currently is 1,600. And ask you to have the exercise for the previous example. All right, so there you have 3 minutes to have the discussion with your neighbors. And if someone wants to serve as a presenter, welcome. And there you have 3 minutes to think about this example. It's an easy example. And, sorry, way to have the answering. Let me show you the hyperlink to our line group. So let me measure. Anyone finish it? If yes, you can upload your answer and share your answer and share your idea. So if you want to do so, sure. Welcome anyone to maybe invite one to have the presenter. So you want to do that? Yeah, header 20. Likewise, we have 20 bytes for IP header. Once you finish, you can upload and allow you to share your answer. For all of you, you should upload your answer before 4 p.m. today. But I try to seek the presentation from one of you, if possible. In fact, it just repeated predicts for the previous example. But we have the new problem here. If you want to share, at least you can upload your answer right now. And I allow you to have near 1 minute to have the presentation. Let me confirm with you again. Anyone want to have the presentation? Yes or no? Oh, I've seen one. All right. From Guanci, you want to do so? Okay, sure. You can double click on that one. So, using my, okay.
There will be 4 fragments, and their length is 500, 500, 500, and 80. And their offset will be 0, and 60, and 120, and 180. This is my answer.
Okay, good. Just for reference for the other students. Okay, yeah. Great. Thank you. All right, so this is the reference solution to all of you. If you want to check these, sure, feel free. Why I allow you to do so? Because I allow you to learn collaboratively. So it's okay, even you think, okay, something good, something wrong. If something wrong, hopefully you can let her know. And that's it. So we have the presentation from Guanci. And Guanci, if you can have the remark, you are the presenter, you can do that one. Or maybe I will check it later. All right, that's all. This is the TPS of today. So let me close the class of today. In the second class, actually, we directly have the middle bus, mainly for the middle bus, and the important one should be the fragmentation. And finally, I arrange a TPS for you, this one. All right, so that's all. This is the discussion in the second class, and see you this Wednesday. We will start from chapter 5 this Wednesday. Bye-bye.